Let to join. Yeah, session is being recorded. Okay. So if anything, we can start. I believe. Then we will go ahead. Over to Rahul.
So can I start session or need to wait?
We can start.
So firstly, we start the session. You basic about our ROS two, like our ROS two nodes, ROS two topics, and ROS two publisher and service subscriber and service and client. Just this thing you need to in the your all the Robothon's session. So just I have a given idea to loss to node, loss to publisher subscriber, and client server. I am not giving here any lesson about like loss to action, turtle sim, and different things. Is audio is audible? Am I audible?
Yes,
Hello.
sir. Yes, sir.
Okay. So we start this session basic about loss to nodes. After ROS to node, we understand ROS to topics. Then we understand publisher subscriber model. And then we understand the ROS to client server service basic. Then we move forward to Mojoko, basic about Mojoko. Then we implement a whatever you find a repository about like Docker image. You find everyone find. So we start the our robot S0 SO arm 100 lay robots. So I given basic idea about like uh, how many degree, how many per joint, how much angle is rotated. uh, Basic idea. Then we route to and move it. Mm. So you have a basic idea about everything. So whatever project and a problem statement you choose, so you do work best on it. Okay. Hello.
Yes, sir.
Okay. So anyone know what is a ROS to nodes? How it work? Hello. And you know anyone know about ROS to nodes or node or anyone know graph theory? No. Hello. This session not just I'm giving you a lecture. You can.
No, sir. A node can be of a publisher or a subscriber. So a publisher node always publishes some data. So, for
I'm not
example,
asking about listen, I'm not asking about publisher, I'm not asking about subscriber. I'm just asking about what is node, not extra, just basic. So anyone know about graph theory? Not perspective of topic publisher subscriber. So think node nothing is a like a program. You write a program Python code. Node like you think as a individual person. So individual person can act as a publisher or can act as a subscriber, right or wrong? Hello.
Yes, sir.
Individual node can act as a publisher. Uh, Individual node can act as a subscriber. Individual node means anyone, any person, anyone can do. So node is just not a big things, just a program, just a person, just a you can say anything. So just a single function we can say that we can say that also one sensor, like IMU, like a camera. This is we can write a code for just extract an image. So this camera we are extracting one image, one frame. So So camera is a one node. If we are extracting data from IME sensor, so IME is a one node. So node just is a responsible for single or modular purpose. But we can do many tasks using a node, but we can do using a node single or modular single task. Very simple. We can using a node. So node can act as a publisher. Node can act as a subscriber. So publisher, who is publisher? Who providing a data, right? Or whatever person is listening that data, that is a subscriber. So each node can be act as a publisher, can be act as a subscriber. So each node can send and receive data from other nodes. Nodes uh, publish or subscribe data means send or receive data from different communication medium. That medium is called as topics, service, action, or parameters. Understand or not? Hello.
Yes, sir.
So node nothing you can say that it is a simple one program or function. Okay. Okay. Hello. Okay. Next. So when you work on in a ROS 2, so you need to about whenever you start any programs when you launch your ARM. So when you in another terminal, just write a ROS 2 run or package name and node name. So you can find a specific node from a package. Means when you work on your ARM, so in my case, we are working on which arm? SO101, right? So here each package is SO101 underscore Mujoko. And after S after writing out SO101, then we write a node name, whatever node name you given, like a node name, like a person name, like a sensor name. So node name we can also write in a code. So no need to worry about this. Using a ROS to node list, we know the whatever number of nodes is currently active. Means you are in the class. So how many person is presented in the class? So how we know that using a register or any other medium. So same way we using a ROS to node list, we know the currently running nodes. Understand or not? Hello.
Yeah.
uh, need to know about any special person. Means in the class, uh, uh, for example, 40 student or 60 student is present in the class. So we know, uh, I know one person is come from the outside the class on need to information for a specific student. How you know that? For for this, we know call that particular student and then extract the data uh, class name, how many subject is chosen, or there are different type of information we can extract. So same way in the programming or in the ROS, so we can need to information about any specific node. So we can write a ROS to node info and node name. Whatever name you are giving, like you are giving name, my name is just like Rahul. So you can write a name as node name Rahul. You can write name as a whatever type of program you are making. So same name you can give it like a robothon. This hackathon name. So we can write a name as node name robothon in the program. But when need to information about node robothon, so we write a ROS to node info robothon. So whatever data is providing this person, so we can get using a terminal. All these things we try using a like a practical, so we can know detail. So like here we go through node list. So we here node presented two, tail tail of turtle and turtle sim. So then we write a loss to node info or a node name is a turtle sim we are using. So here we know Turtle's subscriber, publisher, node Turtle Sim act as a publisher, also act as a subscriber, act as a service server and action server. So here in one node doing task, how many? Subscriber, publisher, service server and action server. Then we know we want to run a specific code like a program. So ROS to run turtlesim is package name and turtlesim underscore is node name. Okay, or like a file name. Just simple. Now we understand about topics. Topic is a communication medium. Okay, a topic just a communication medium. In ROS one, topic is synchronous. Sorry, asynchronous. In ROS 2 also topic is asynchronous. ठीक है? So topic are name buses, which using we can exchange our data. So like in this robothon session, we are exchanging my knowledge all of you. So which buses we are transfer knowledge using robothon hackathon session. So this name here topic name is robothon. So topic are name buses which using which uh, over which node exchange data. So node is we one node me and there are different number of students presented in this class. So all this person is node and we are exchanging data using a topic robothon. Okay, topic are intended for and unidirectional. Unidirectional means one person at a time, one person can send a data. Means one directional data we can send. Means I'm publishing data, unidirectional. So I can't subscribe data. Okay. But like a think as a unidirectional both side data is not transferred. Simple. And asynchronous, I'm sending a data. I'm not worried about any one person my data is listening or not listening. This is asynchronous streaming communication protocol. Okay, there can be a publisher subscriber to a multiple publisher subscriber can be exist in a topic. Means I can I can send a data. I'm a only one publisher and many students listening our data. So one publisher, many subscribers. Then I'm asking one question to all of you. You are giving answer to me. So many subscribe publisher, one subscriber. Same way, all of the student asking some question to me. I'm replying also, and with me, many other member are present. All of the answer is given. So many publisher, many subscriber can be possible in the ROS 2 topics, in ROS 1 topics also. ROS 2 topics using DDS protocol and ROS 1 topic using TCP ROS. Okay, communication medium. Okay, transport topic are not only allow one to one publisher and subscriber communication protocol, but also support one to n, what means one to many, many to one, or many to many, depending upon the purpose. Okay, when a node publish when node publish a data, so it publish a data uh, to a particular topic, and particular topic receive a data specific message. Means robothon session which are doing at that now. So we are here get a knowledge about like ROS to Mujoko or move it or different specific knowledge. But here we are not know about many more things like a differential drive, any other type of robots, because message is defined here for robothon session, which information, whatever type of information is needed. Okay. So ROS 2 topic, basic about ROS 2 topics. Anyone have doubt for ROS 2 topics? So then we go to next slide. Hello. Any doubt? Hello? Hello? I'm audible or not? Any doubt or not? So then we go to next.
No, sir.
Okay. Then we are here. Using this image, we can understand the detailed knowledge about the topic. Here, one node is this, one node is this. This node as act as a publisher, and this node as act as a subscriber. So this node is publishing a specific type of message to a subscriber, and subscriber extracting a data using or receiving a data for specific topic. But this media communication is one to one. But a node may publish data to any number of topics and simultaneously have subscription to any number of topics. Means any one node act as a publisher, subscriber at a time in ROS 2. But in ROS 1, this thing is not possible. So here you can see that one node also act as a publisher, also act as a subscriber. Okay. Now, so when you are working on ROS 2, so where how you know how you know the how many topics is active or not. So first we are launching here robotic arm, and then we know the about lost to topic list and many more things. So via experiment you understand more, I think. Once a second. Don't worry, I teach about how to launch robots and load a robot in Moriopo and all this thing. Just I'm giving up basic knowledge about ROS to topics, so that's why I'm using here.
Sir, you are using VirtualBox, right? Rather than using dual boot,
Mm,
you are using VirtualBox, right?
I'm using WSL, not not no, WSL. Windows
Sir, I
supported
didn't.
Linux.
Sir, I didn't get you. Can you pardon?
I'm using WSL, not a VirtualBox, not a dual boot. Any my system. WSL is a Windows supported Linux.
Okay,
Huh.
sir.
Uh,
Does it support Gazzy
you need to know about
relationship?
okay. You need to know about how many topic is currently active. So how you know about how this thing know about using a ROS to space topics space list. Same way, if we are using ROS one, so simple you can write a ROS two is ROS topic list. But here here I'm not giving a lesson about ROS one, so just ROS two topic list. When you type a ROS to topic list, so you see the all the ac- list of activated topic. Just wait a second. Okay, here you see the all the topic name. This topic is for camera in your arm attach D435i depth camera. So camera info means a intensity parameter, depth image, color image, points cloud, and this this is your movie plannings, and this topic is movie planning also, and this is your joint angle. This using this topic we know the joint angle. Okay, so you know the ROS2 topic list. So here, how many number of ROS2 topic is presented? Th- there are different type of topics, but ROS2 topic list. Just uh, you need to know about this topic act as a publisher, or this topic act as a subscriber, or this topic which type message is subscribing or publishing. So how you know that? Using for this, you can just type route to topic list. So you know all these things in one place. Route to topic list or hyphen V. So wait a second. See, you here you see there are number of publisher and topic name is attach collision object. Message type is move it underscore MSG. And specific move it underscore message, there are different type of uh, like a so attach collision object is a one data type. It just you think as a simple programming language. So float is a one data type. So here attach collision object is a one data type. Okay, like depth camera is a published topic, and because camera is publishing topic, not receiving anything data from you, right now. Camera, IMV, they all these are publisher, not a subscriber. Motor is a subscriber, right? Hello.
So can you tell what exactly movie does?
Move it are just a path planning framework. Using a you can using this, you need to know like a RRT planner. RRT RRT do path planning using a different type of algorithm. RRT A star. So move it just a one uh, platform, or yeah, one tool. Using this, you can plan the your arm path, like I'm so to you, so you can understand. Here you see your lay robot with a your depth camera. You see or not?
Yes, sir.
Now you plan. Wait a second. One second. Here you see how many joints present. One second. Sorry. How many joints here present? Five. Shoulder pen, shoulder field, left or elbow. But you need to planning your motion. How this type of motion is work. So there are different type of. Forward kinematic or inverse kinematic.
Yes, sir.
Hello. Uh, Forward kinematic means
Finding the end
you given
effector
a
position. Finding the end effector position.
using given a specific angle, we can get a specific position and effector position. Right. Right. You are providing any or a specific angle or
Joint angles.
specific joint angle. So using a forward kinematic, find a end effector position. But for inverse kinematic, you giving a
Joint
position of
velocities.
inverse. No,
We
no,
find the
you
joint
giving a
velocity.
just uh, find the joint velocity. So move it. Uh, you are giving a specific position to reach arm. So you moving inside using a different type of planner inside. Planning group, planner. Planning group means you make a robot, one robot, and means a different type of means you can think as a link and join combination, and set is a one planning group means whatever name you want to give it, like simple. In this case, we are using arm, and but you are giving one path, but this part using inverse kinematic, we get a number of different type of solution, right? Inverse kinematic never give a one solution. Inverse kinematic give a different type of solution. Reason is singularity. Most uh, so motion play using move it. Dive you can plan. No need to start everything by basic means forward kinetic, inverse kinetic, or all this thing. So all this thing is already set up in move it. Uh, all type of planners, which is famous planner like RRT Star, or uh, there are different type of planner. All name I'm not know at that time. So move it just think as a planner, not much more I can say to you. Understand or not? Hello?
Yes. Sir, can I simulate
Just
this in gazebo as well?
yes, yes, same way. Most of the person is using Movit or Gazebo is together, but this physical AI uh, webinar or physical AI robothon. That's why we are giving our idea about Movit with Mujoko. Most of the person and most of the lab using Arvij and Mujoko together for motion planning of robot, any
Sir, will
type
you
of
provide us
robotic. I'm like,
this repository to run
yes,
for
you
practice?
if you
Can you
are
provide us this?
hello with
Yes, sir. I'm
Garibo.
asking. Yeah,
All
if
the
you
things.
provide this repository, we'll practice.
Yeah, yeah. The docket will
Yes, yes,
be
sir.
for
Yes,
data
sir.
training and all the things are being actually there was small error in URDF. The team is working on it, so that's why it's delayed. If not, today only we would have sent. Yesterday or today we would have sent. We are expecting
Okay, sir.
it to
Okay, sir.
be rectified soon, and we are sending it by today or tomorrow morning.
Okay, sir.
So you know about ROS to topic and ROS to topic, how many number of topic activate a topic, how particular node act as a mm, publisher or subscriber. You know all this thing about or not? Hello, clear or not? Everyone, please say. Okay. Up. Let's. I'm here and not launching a like a your arm. I'm stopping this arm. I'm launching a just simple basic differential drive robot, and all this practical I'm showing it to you. A differential drive, like a publish a data using a terminal, or subscribing a data using a terminal. Same way you can do all these things with arm. Or then I am giving basic about idea about move it. Then I can also extract the data using with the arm. So you want to see with a uh, arm or with a differential drive. So I can start with both or with arm. Listed. Hello. You want to see all this thing data extraction means printing your data and visualizing arm data means camera data. So with a differential drive or with your uh, robot arm. Hello. Okay. Then I start with differential drive. Here I am publish start a differential drive robot. Wait a second for when this robot is launched, so I can. There are different terminal topics, terminal method. We can know about information about ROS to topic info, ROS to topic info, or a specific topic about if you want to knowledge like CMD well. We know we want to knowledge about CMD well, so you can type a ROS to topic info. Uh, I'm saying show you one method ROS to topic. Uh, Direct ROS to topic V. So we know all this topic uh, in a one place, but we want to knowledge about one specific one person. So you can type a ROS to topic info specific topic name. If you want to know knowledge about together all means in the class 40 student is presented and you want to knowledge about all the 40 student in means together, so you can type a ROS to topic list space hyphen v, so you know all the topic information in one place. If you want to knowledge about one topic, so you can type a ROS to topic info topic name specific topic name. For example, CMD well, so CMD well. अब you want to print the data about one topic, ROS to like a ROS to topic eco. So just here we see the data. Like you are seeing this robot differential type. Up now I want to see data. So for this we just write a ROS to topic list. So you know all the topic. Here you see the topic CMDWell, ODAM, parameter events, and ROSOut. Parameter events or ROSOut is by default, CMDWell and ODAM for this robot. So we write ROS to topic list V. So here you know ODAM message type is name underscore message, and here CMD where geometry message type is geometry message, or twist type data we are publishing here. Subscribing data is odometry type. Now we you want to see data of odem is actually subscriber, and odem tells about where robot is actually exists. So using ROS to topic eco, just simple, you type ROS to topic eco ODEM. So you see the current position of the robot. How? See, lost to topic position. Position is in the x 0.000 means 0, in y same 0 and z 0. And but in the ground robot, x, y and theta is important. So using orientation, we can calculate a theta. Okay. Now, if you want to publish a data using a ROS to topics, so you can publish a data ROS to topic pub. So same way I am also here. So ROS to topic pub hyphen once topic name is here. In our case, it's CMD well, but I am in the PPT showing title one CMD well. So same way message type is geometry underscore MSG twist. Same you know about it. When I show you using ROS to topic. Uh, Wait a second. Yes. Here is your topic message name geometry underscore MSGS slash MSG slash twist. Using this, you are publishing data linear. In the linear, we are publishing X is 2.0, Y and Z 0, and angular velocity. Same way you can publish the data. Now, for extracted data, after publishing, you want to see eco CMDable data and also uh, eco data. So you can do. And information about specific topic. Lost to topic info CMD well, so you can know about information of specific topic. So this is basic about what is node, what is topic. Now, basic you need to knowledge about workspace. What is the workspace? How can we create a workspace? In your case, no need to create a workspace, but basic knowledge of about workspace you need to understand, because if you are doing write a code in a workspace, so this thing is mandatory. So how you create a workspace? But first I need to understand what is workspace. Anyone know? Hello? Anyone know what is workspace? What is package? And how we create a workspace in ROS 2? Hello? I'm audible. Think workspace just is a like a think mm, one place, one room. It means workspace. Think as a simple one college. So inside one is workspace means college is workspace. In the workspace, we there are different type of classes. So class is class you are think as a package. So workspace, you can in the ROS or in the ROS 1 or ROS 2 workspace, just to you can simple as state as a folder creation. So using a terminal, how we can create a folder? Just a simple typing mkdir. Mkdir means make a directory, and then workspace name. Like we are here for Robothon session, so what I'm giving workspace name in Robothon workspace. So simple mkdir Robothon workspace. So your workspace is actually created. So how you see that? Using ls. So here you see Robothon workspace actually created. But workspace is created. But means your college is actually outside is prepared. But inside nothing is created. Means no class is created. No structure is created. So for this we need to first set up a gate. So for this gate need to go for going in the into your college or into your school. So first we go to in your workspace. For this we can type a cd robothon underscore workspace. After that we can create a one folder that in name is source, like at your gate in your college or in your school. So first we create a SRC. This folder is mandatory in whatever ROS version you are working in ROS 1 and ROS 2. This folder is mandatory. So first we create a SRC. So your gate is actually created. And now you are starting your creation of packet. So where you start creation inside your college gate you enter, and then one by one your package is created. So first we go to inside in SRC folder. CD is actually change a directory. Simple. Now you are creating package. For creating package here in the last one, package creation for Python is different, or for C++ is different. In the ROS 2, just simple one command you can create a Python or C++ package together, but not ROS 2 together you can package create. So first you this thing you need know about. So step of creating a workspace, we need tool specific that is called on. First time creating workspace before any in your case everything is set up is provided. But if you are not if you are starting by initially, so first you need to install Qualcomm tool using a command sudo apt install python 3 Qualcomm common extension. But in your case no need to worry about, because all all these thing is provided by mm, in your image Docker image. So no need to work respect. If you no need to worry about step one also, right? But step two also no need to worry about. This thing also provided, but just I am giving idea to now. Here for creating package, in creating package I'm go worry about step 4. For Python package, we just write a ROS2. Means how you create package. So first you ROS2, because you are working in ROS2. ROS2, then you need to create a package. So you write a PKG. PKG means package. Then you write a package name. Whatever name you want to give in package name, you can give in go given about. Like we are giving whatever you project find out. So I am in your case I show you HO101 underscore Mujoko. This is a package name. You can give it same package name for your case. But if same package name exists, so you can give one package name means any different type of package name, like you name written on your name, you but you are doing a session robothon work. So I'm giving here package name is robothon, but you can give different type of package. Then you are building which type of package? Python type. So build type. Then you write a build type. Then write a which type of package is creating Python or C++. So if you are creating package in Python, to write a amend underscore Python. If you are creating a package in C++, so you write a amend underscore CMake. Then dependency, and then dependency. After you write a space RCL Py for Python. If you are writing a amend underscore Python. If you are writing a C++, so you write a RCL CPP. So step 4 we also do. First you write a ROS2, then PKG, then create, then with package name. So I'm here writing a package name is Robothon PKG. Okay, whatever name you want to give in your package name, you can give free to give. Then after this, you write a build type. This is important. Build type. Same you can type it. Copy from here. So you can just 1 second. Just this way, not now. Now you understand. ROS to I say you ROS to package, then create, then your package name. Package name here I am giving to robothon underscore pkg. Then build type. Build type means which type of package you want to create. Build type here is Python. So build type after you write a amend underscore Python. Python. Then dependency. You are because in physical AI most of the code is you are writing about in Python, not C++. So I'm also giving idea about how to create a package in Python. Then dependency is RCL Python. Just you can type and your package is created. Now, so here you see your package is created name start with robothon package. If you want to create a package not in Python, you want to create a package also in C++. So here we write underscore CPP. Then we write a same, nothing different. Build type, then write amend CMake, and then write dependencies, and then you write a RCL CPP. CPP means RCL Pi means ROS client library for Python. RCL CPP means ROS client library for uh, C++. Okay, okay. Then now your package is created for C++ also. Okay. Now you can go into inside your package means now your two classroom is created, one for C++, one for your Python. Same way like I two a class is created in your college, one for higher standard, one for UG, one for PG. Okay. So now we go to inside your Python package. Here you see this XML file and set the source file, XML file, find you setup.py and Robothon package. So whatever you are writing your notes means your Python code. So you write in Robothon underscore package. Inside this package, you write your all Python code. Whatever Python code you are written, all your Python code means in your Robothon session, all Python code here is written. Also, when you see uh, your course where you written 1 second, when you see like lost two, this is your package, and see Your Python code is written in here inside the script folder inside the same SO101 underscore Mojoko package. Okay. Any any person have doubt how to create package, how to create a workspace? Hello.
Sir.
Now, how to build package? Now you created a two package. One is Python package. How is your C++ package. For this, first you need to go your workspace. Like our workspace is Robothon workspace. Inside your workspace, you can type a just call code build. Using this, your package is build. So here we are creating two package. So both package are building. One is Robothon PKG underscore Robothon underscore PKG, and second is Robothon underscore PKG underscore CPP. Both packages build. After that, you can utilize. For this, whatever type of terminal you are working, if you in your case you are finding a one image, so no need to this thing type of, like a source install setup dot bash in all your terminal, because this thing already do in your docker image inside the bash folder. But if you are not doing this thing in your inside bash folder, so every terminal you need to type a like a source means you are every time calling after building package there are different type of dependencies, means rcl pi dependencies, and means or geometry type, whatever type you are message you are utilizing in your code, all these dependency which is already open sources and no need to worry about you. So all these dependencies is built in your package. So when you type a source and install, so whatever type of dependency is built, it's set up in your uh, terminal. Okay, so I think that uh, all of you know ROS2 package, all of you know ROS2 workspace, how you create a workspace, how you create a package, how you know basic about Node, you know basic about uh, like a topic, you know, publisher subscriber model. So publishers model is a just think as a one person sending a data. So that is a act as a publisher, and one person subscribing a data that is act as a subscriber. So this is just a topic is working on publisher subscriber model. So anyone have doubt any topic till now? Please ask, then I go to programming part. Hello.
Sir, in ROS 1, there is like ROS master, right? In ROS 2, is
Yes.
it automatic communication or just like ROS 1?
ROS one is centralized system using a TCP ROS we can utilize it, but ROS two is not centralized, decentralized. ROS two is using DDS, so no need to start about ROS master. Here direct is you when you are launch run a node. Your means publisher no need to register from a master node, and no need to register subscriber from a master node. Means we can directly communicate to you. No, simple think like that. In ROS one supervisor is between publisher and subscriber. If anyone I want to do, means I am publisher, I want to anyone to do, so first I go to supervisor, give information about, and you want to know information about particular topic, so you go to supervisor, that supervisor, and extract information from that supervisor. So ROS2 work on this medium, means centralized system, but sorry, ROS1 work on centralized system. But you want to work on working on ROS2, ROS2 no work on centralized system, is work on decentralized system, means directly you can communicate with me. Okay,
Okay,
any
sir.
doubt? Now, any question? Any other question? Hello, hello. Any question you can ask? Then we can go. One write a code, publisher, subscriber. Simple. Hello. Okay. I can think that no one have any doubt. Please ask a question because if you are not asking any question when you are working, I know the all repository I am providing or our team is providing all the repository and one Docker image. But when you are working in this Docker image or all this setup, many errors is coming with ROS, or I can also challenge many times you are using any type of AI like Claude, ChatGPT, many times no solve, not solve. So you need to know about basic. If you know basic, you can solve any problem by 1 to 2 hours or many person to just in 15 minutes. So please ask a question. Okay, let's go to. I'm writing a one code publisher subscriber. So for writing a code, just see. I'm also writing one code uh, for differential type. So I'm going to inside differential type. You see inside SRC, I am creating a one packet differential type underscore Mujuko. Same name inside. I'm writing a Python code for a differential type robot. Okay, differential type also one Python code Q learning. So here I do one just name is Q learning, not a publisher subscribe model. Here I am written for you. So first line, you see first line in the code. Hello, hello. Please apply with your answer. Okay. First line is in many person when you see in this code. So first line everyone think as a this line is just a comment, but no, not true. First line is actually written for environmental setup. Where is your Python environment is exist? Where your C++ is environment exists? Using this line, we can write a give a uh, our ROS ROS program or our ROS code. Key Python code is, environment is that place. So using this line, if hash does not equal to slash USR means user slash bin inside your bin folder inside bin folder you Python 3 environment exists. Now second line is importing your Python library for ROS client Python library for writing your code. So import RCLPy means you are importing your client library, ROS client library for Python. And now you are in your ROS code. First, some basic you need to write a one node, start a one person means you are giving one. You are creating one person or one sensor. So using like you if you are know about objects you know about this so if you are know about objects so simple think as a object if you are not know about objects so you just think as a one inside one function you are extracting one variable so from rclpy dot node you are inside extracting one variable node. Okay, now this is your message type. How you know, how I know, how you know, using just typing just simple ROS2 topic v. So message type you know for publisher geometry underscore msg or dot msg. Then extracting a specific data type twist. So geometry underscore msg dot msg. This is your message type for publisher subscriber, and this is your data type. This type data is used publish in your robot. This type data is linear tool velocity and what angular velocity. Now extracting data means you are extracting odometry data for you know how you know message using this. Odom is your topic type, uh, topic, and your message is naive underscore message msgs dot msg, and extracting your data type odometry. Okay, this is your this thing any program any program whatever program you are writing, always program start with where where main code. So this is you are calling main person asks means arguments. You are passing one in your function, nothing argument, so you are writing args equal to none. When you are passing a different type of parameter means different type of arguments, so you can write a args equal to different whatever you are arguments passing. But here inside our case we are using nothing arguments. I'm not passing any arguments. You see here means no parameter is passing. So rcl pi is those ROS client library for python. Dot init means initialization of your node. Now when you starting your node initialize, then after initialization you giving a node's name. Node name means you giving just like when you born in your house, yeah, one baby is born in your house, after some days, after month, giving a name of that baby. That's same way after creating a node you giving a node name. So using we are creating a class after when you call a class. So class is calling a constructor after constructing a first program is run where you giving a node name. That's so that node name is passing to here using this. So here is args equal to args equal to is args means you are creating your node name. Whatever node name you where you give provide you extract from there. Now after calling a different drive controller means this class, so your node is actually created. So first you go in your class. Class in name, uh, how you create a class. Simple, write a class and your class name. After here you pass a your node name, whatever you name you are providing. So this will you pass. So when you call a differential driver class, by default constructor, this is calling, and after calling this constructor your node name is here. In my case I'm writing a node name is different drive diff drive controller. You can here change our node name is anything. So how you know this name is created or not? So simple, you write ROS2 node list or not. So in my case, I'm not any this program running. If you are run this program, when I run this program, so this node is actually created, but I am not at that time giving this node name. How you I am running this code, so you see the also same. Wait, 1 second, give me a time. So I see. So you node name. See here, I am giving node name is diff drive underscore mujoko. Same name here. You see. Okay. Anyone have doubt? Okay. I can think as everyone understand. If anyone have doubt, please ask. Now, after calling a constructor, now we are creating publisher model. So how you create a publisher? So for creating a publisher, how many things you need to know mandatory? Publish means topic name. Publisher means publish a data into a particular topic. So publisher need to information about topic. Which topic publisher is publishing data means one node. Where is publishing data? So my topic is publishing for the publishing data is CMD well. CMD well means we are sending data. CMD means command. Underscore well means velocity. We are providing a velocity. So velocity provide to a motor, right? Motor is receiving data. So we are providing a velocity. So we are publisher and motor is receiver. Receive the data. Okay. In your same in with our case of ARM, CMD well is uh, publishing data topics, and message type where you see means twist, means data type is twist, or means we are sending one data, so some delays happen. So how much data you want to store means how much you want to queue size. So here queue size is 10. Now, when you are creating a class, so by default constructor calling the class, so self in need to create self dot create publisher. Just this method, I don't want to write a many always when you want to publish a data, so write a self dot create publisher and then all these things uh, many more times. So we write a just a store in a one variable cmd well pub. Anyone doubt? After means we are publishing I'm publishing data, I'm not publishing continuously data, just on 1 millisecond, microsecond I'm sleeping, means I'm sending data, just stopping, then again sending data, like this. After publishing data, how much time you want to wait, means you want to sleep to for this here. We are using timer function. Self dot create timer function. How much time to wait? 0.16 millisecond. Or which uh, which type of data means which data publish after you want to wait. So self dot publish CMD well top whatever you are variable created. Self dot timer is also one variable. Now, you are publishing data, you are creating one variable. Not and now at now we are not publishing any data. Just we are creating how you publish a data. After publishing data, how much time you wait. Just two variable stored because we want to write a full like a full line again and again. We write a code minimum to minimum line. So after now you want to know the current position of the robot. How you can know? Self dot create publish. Like a create publisher, you are creating publisher. Now create subscription means you are subscribing data. Okay. For subscribing data, which topic you data subscribe using ODAM. Using ODAM, you subscribe the data. So topic name is ODAM, and here your data type is odometry or message type you know already, odometry. This is your data type. This is your topic. After topic, this is your queue site. And up when you extract the data means you are printing data or extracting data. So which topic you are extracting? Self dot odem callback. This topic when you write a odem callback, here you write a your function odem callback or your data is extracted. How you know? This thing I can explain you. So first we go to self dot odem callback. Here, first variable is whenever you class create a class function inside your class. So first parameter is always is self, and second is message is your which type data type is automatic. So message dot pose. Now you how you know this thing? So for this, just you type a ROS to MSG info or echo like this. I think once can. I can give you one after 1 second. Okay. Message inside your message. Pose, pose means position. Inside your position. Just simple. Wait a second. How you know? Just lost to eco method. I so see basic code understand. See inside pose lost to message. Your data type is automatic, so you can store it in the variable message msg. Message, your variable name is msg. Inside msg you can go, means when you write msg, so you go inside here. Here now you extracted data from pose, inside your pose, and then your position. Now position you can extract in X, in Y, in Z. So message dot pose dot pose dot position. So you know the position, all these axes, X, Y, Z, not orientation. If you want to know in position in X, so then for position we type up msg dot pose dot pose dot position. For orientation msg dot pose dot orientation. Right here you see message dot pose pose or orientation. Now, now you extract the position orientation. Now you want to extract a linear velocity. How much velocity is published by any person? So same. How you can write message dot twist dot linear. If you want to extract a linear velocity, if you want to extract a angular velocity, same way you are. But you want to not linear angular velocity. You want to extract a linear velocity, angular velocity together. To simple, you can write message dot twist. Now self dot get logger means you are printing your data using logger function. You can simply print the data using a print function, but I am using here get logger simple because I'm using a official information. So printing a linear velocity and position. So in pose dot x, you did you store the all these things inside one variable pose dot x. Pose dot x means you are extracting data inside here, inside this. Now you want to extract data x, so you write a post.x. If you want to extract a data in y, you can write a post.y. So you extracting OW. Now you want to extract a linear velocity in x, so twist.linear.x. If you want to extract information angular z, twist.angular.z. Now I think everyone has how to subscribe our data. Everyone know. Now you want to publish a data into any any topic, any topic. So now your message type is twist in publishing data. So first twist I can write same way like just we create a function. So here you can also write a message equal to twist, but same whatever method you want to follow, you can follow it. Twist uh, uh, twist message is stored in message. So message dot linear. See, when you are publishing data, so first you write to message type is actually lost to topic pub cmd pub, and then you write a cmd well. That using if you want to send a data, but not CMD well. I cannot, but I can think no, but no problem. I can give. Uh, just message dot linear simple. Twist inside you twist go message dot linear dot x. You can publish a linear method, linear data. So message dot linear dot x, you can send a data in linear x, linear velocity in x. So self dot linear x, you can here I am store of in linear x में four values 4 meter per meters per second velocity, but you can also send a more less whatever you want, or you can also get by user using an input function using a GUI, any medium whatever you want to choose. Self dot linear x, you can here set velocity, linear velocity is 4.0. Here angular velocity is 0.0 because I am not sending linear angular velocity. You can also send a angular velocity. So message.angular.jet, you can send our data using publisher. Now you sending a data inside one message means inside twist message linear velocity is 4 and angular velocity is 0, but not now. You are sending data uh, making a one message type format. Not now you are sending data. For sending data, you can you are storing all means you say the like we create a model for publisher. So twist in this variable self dot cmdval underscore pub dot publish. You now you are inside this publish self dot cmdval dot publish. Using this, you are sending your message msg inside this. So angular and linear velocity you are publishing to robot. This is all this thing is done. Now your code, and here you are write rcl pi dot spin for holding your window, because if you are not rcl pi dot spin not right, so your window is not hold, and whenever you code run and then code your code is some minutes after it stop. Now everything is right. Now I'm just running your python code here inside. Just wait. Now see Python 3. I can run Python 3. See, now your robot is moving. Very slow. Very slow. Yeah, but see, now your robot is moving very slowly, but continuously is moving using linear velocity. Here, you can also see your data in your robot. Whatever thing we are testing. Odem X in X your current position is 0.037. Y in your Y in your robot in Y direction is 0 point 0. Linear velocity 0.068 is continuous publishing. Angular velocity 0 is publishing. So you can see that all these things. So I can think everyone now understand how we write a publisher, how we write a subscriber. Inside one code, I have given both knowledge about publisher and subscriber. You can do different way. Now, if anyone not to run a code using a direct Python 3, anyone want to run a code using a ROS to node package name and then package your whatever node name is given this method. For this you need to go inside your package setup dot py file, and inside entry point you can write your uh, first your package name. My package name is different diff drive underscore mojoko, and then your python code name. Like in my case I will just make one. For this I make a like a direct method, ROS to node method. So mm, diff drive ROS underscore ROS, and then because all these your code is start by main function, I say I say to you, so write a main, and then if you are want to run, so now your code. After that, after doing this, you can build a package, and then you see ROS to then your package name, and then whatever node name is given means entry point in name I am giving here diff drive nodes. So I can think as everyone know now publisher subscriber code working. Anyone have doubt? Please ask. Because after this, I am going to client server model. Hello. Anyone have doubt? Hello. Okay, I can think it. Everyone know, understand the basic. Now, ROS to services. Service also a communication medium like a publisher subscriber, but not a exact same. So how this medium is working? So everyone calls the parents always, not daily, sometime in a week, sometime in a day. So when you call up parents, so first you after calling, you say hello. If your parents is not replying, some minutes, some second, so you think as a call is not actually connected, nothing is. So client server means service, lost to service is working is same as. But in ROS one, ROS to service is synchronous. In ROS to service is synchronous. By default, it's synchronous. But when you are working inside your code, you can also create a service as a asynchronous. So in the ROS service are communication methods that allow node to send a request and receive a response. Means when you are calling your parents, you are after calling you are requesting, means you are saying hello. If your parents is replying, you are saying means response is you find. So you are maintain a communication using client server protocols. So it is a synchronous communication medium. Means after sending you are sending a data, you are waiting for a reply. Means waiting for a connection. If you are not maintaining, if I'm send, I'm if like a thinker, I'm uploading a video in YouTube. Everyone person, any person, one. Uh, if I am uploading a video in YouTube, one person see video, two person see video, I don't know about. Many person is together see video, I don't know about. Because this medium is after uploading a video, I don't know about any one person. I'm not maintaining any communication between any person, all these person. That's that medium is synchronous medium. But at now we are doing a session. Here all student is presented, all one everyone is presented. So we are maintaining synchronous communication. Every time I am asking to you, all this person, everyone understand. If someone is asking, you want to answer, want to ask a question, any all this person, all this everyone whoever is presented, ask the question. So maintaining a communication means synchronously we are connected. So it is a synchronous communication medium, meaning that client node wait for a response from a server node before proceeding further. Means after sending a data, you are not doing any other task. You are waiting for a response. In ROS one, this medium is working. You are sending data and waiting. But ROS two just asynchronous means after sending data, you can do any other task and you are not waiting for it, but you are maintaining the one in communication. Okay. So services are defined using .srv file. Means here message type is your .srv, but in your message type is publisher subscriber, your message type most of the you see which file .msg file. Purpose of raw service are primarily used for interaction that require specific response or confirmation. Means I'm now think at it. Your robot is sending to a 1000 many far away. So you want to maintain a connection because you are not going with it with that robot. Means you are sending your drone 10 kilometer far away, and now at now you are not seeing your drones. So how you maintain a formation? For this you need to set up a client server, and you want to fetch a data from your robot. Means it's access a specific time. Let's you have a 10 number of drones, 10 number of robots. All robots have a different type of all robots have on camera, but you no need to see the all camera data you need to see specific drone or specific robot data. So using client server medium or client server method, you can see this. Okay. So, whatever task we can do using this, taking action, instructing a robot to perform a specific action, such as picking an object or moving to a particular location. Means in your task, pick an object, pick a glass, and go to any other place. So you can maintain a client server. So here hero would start the pick the glass from this location and pour the glass any other location. You can do using this client server medium also. Taking action and parameter setting, changing configuration parameter of a node or service. Data retrieval you can do using a ROS2 service. ROS2 service work on a which protocol? Client server protocol. Means request response pattern. And ROS topic is working in publisher subscriber model. ROS2 working on client server model. Request response pattern service follow a request response pattern where the client send a request and wait for a corresponding response to server. ROS2 is synchronous communication for a directly if you see in top view, but ROS2 is also asynchronous, but ROS1 is synchronous, is synchronous. Defined message structure. The request response message have a predefined structure, specified in .srb file. Ensure consistency and type safety. Okay. Here you see two nodes are presented. One node is act as a client service client. One node act as a service server. Now, client client is sending a request to the server. Now server is replying to a client. Now your connection is set up. Now you send the data. Okay. So I can think as a now everyone know client server, but in a one at a time, one client maintain means you see many user now user uh, at a time many different type of website is open together. So one client maintainer means one node maintainer uh, uh, connection between with many server. Also same way one server reply to many clients. This protocol medium also work here. Now anyone have doubt, please ask. Okay, just I show the message structure of client server interface file so you can understand what SRV file means. Here, whenever you create a server .srb file, so three hyphen before you write whatever thing. This is request means I'm just at my case I am sending a uh, one power value means I'm sending four. This is uh, actually power of any mm, uh, but number like a two power to the power two means four. If you are sending nine, so bool b means true or false. So here my one value is sending, one value is response. I want to retrieve. So here it integer int 64 p and bool p for true false and int p. So this is request, this is response, and this is three hyphen. If three hyphen before whatever thing is writing, this is for request, and after this whatever thing is writing for response. Okay, after writing if you are creating a SRV file, so in whatever is you are creating a means client server model, so client server model always set up to with using your inside C++ package, because this thing is working much good in C++ package, not in Python package. Okay, this is a recommendation from my side. If you want to do with like a mm, Python, you can also do, but I am always recommended for C++. So this is basic about ROS2, how can we can work in ROS2. Now we go with basic your arm, whatever we are working, and the arm is actually this is your arm. So here you see your robot. Your robot. First, we know. Okay, okay, wait a second. Uh, Actually, you are find robotic arm have degree of freedom. How many? Six. With if you are see with gear part. If we remove the gear part, so your robotic arm is 5 degree of freedom. So first, your degree of freedom is base. So here you see I am utilizing all these your part. See, this is your base, first degree of freedom. So base linkage you in your URF you are using the base link, or if you are using XML means MGRF XML format in ROS. So same it base link whatever name you want to give, so you can give. But here in ROS, if URF and uh, URA for XML is just a joint type in written different type, but method is same. I can also explain. So after knowing base link, second link is your which shoulder lift. So first you know about after this shoulder lift. Joint two is shoulder lift. Here this is your second joint is shoulder lift. This is slide the second motor in from the top. ठीक है अटैच बोथ मोटर बोथ ये आप हम लोगों को नहीं समझना नो नीड टू अंडरस्टैंड आफ्टर सेकेंड लिंक थर्ड लिंक इज योर elbow flex. This is base, this is his shoulder, this is your elbow flex and connected using a revolute joint. This all this your link is connected using a joint revolute. Now fourth link is because all link have 1 degree of freedom wrist flex. Wrist flex is fourth link. I am providing this link website also, so you can visualize from this. This is your elbow flex, and now next link is this, and all this link is connected using a joint revolute joint. Okay, so all revolute joint have 1 degree of freedom. For revolute joint, I in your means in a XML. One second, I think 1 second XML. Not yes, here. For evaluate joint, 1 second, I also have evaluate joint. And evaluate joint here defined as a hinge type. So in when you are working on means when you are working in XML to type here evaluate joint in hinge. If you are working in URDF, so here you can type joint is joint type is evaluate simple. Okay, so no need to confuse about. And now every joint move a particular angle means have limitation. So base rotate 0 to 180 degree. Now second joint means uh, also rotate 0 to 180. Third joint also rotate 0 to 180 means from joint 1 to joint 1 second, third, fourth. Four joint rotate in how much degree? 0 to 180, and fifth joint is rotated 0 to 360 degree and gripper is rotated 90 degree. Okay, in this case. So you can see that now after this, uh, everyone I can think as a know the now basic about your arm. Now we go to basic about Mujoko. Then we go to uh, your Mujoko arm and how move it is working and basic all these things we know. Okay, hello everyone, understand or not? Now we are understand about Mojoko. So before starting Mojoko, please ask a question, then we go to Mojoko. Why am we are choosing Mojoko for this, not Gazebo or any simulator? Please ask a question. Hello, I'm audible.
Yes, sir.
Hello. All this, or whatever topic I am take to you, everyone understand? Have doubt? Please ask. 15 minutes for asking a question. After that, we start using Move It and Mojoko. Please ask till 8:45 if I have any doubt.
Sir, I have a question actually.
Okay, ask.
So not regarding this, but when are we getting the URDF file so that we can learn simultaneously? Like we can put this all knowledge by doing it ourselves.
Okay, you find out all this thing. I think tomorrow, day after tomorrow, max to max tomorrow. We are working on uh, just one or two issues you need to resolve. After resolving this all this issue, we are providing.
Okay, sir. So
Because
if you say, give
I'm
us very
providing full. Okay, okay. Ask.
so if you give us like very early, then it will be very helpful for us, sir. So we can get a hold of it. So
Yes,
please, sir.
I want to. Our team want to give early as possible, but some issue is in the your URL file. So we are resolving. After resolving the issue, we are providing because if we provide at now, but there's some issue is you find or fetch, so you are you much more for you is hectic because you are starting many person not know about URL, XML or any more things. That's why we are providing a full working URL for XML file for full setup.
Okay, sir. So at least you can give us something other than that URL file means which are already previously there, so we can start working on it. So by just listening this, we can't
Okay,
understand it
so
completely, sir.
okay, we provide like this some links so you can direct understand from there. I'm not providing a Docker image, but I provide you like this your a link for where you how you set up your arm or this thing. So directly
Yes,
you
sir.
can do.
Yes, sir. That will be
But
very much
we
helpful,
are
sir.
not providing n- uh, Docker image provided. I think you get tomorrow day after to max possible, and I give you a XML or Python code so you can understand and how you this thing work. You can know the basic about, and you can work on basic like any type of robots. No need to work on a diet in a your arm, but you if you know publisher subscriber how work package how work. How you create a workspace, how you create a different things, so you can directly work.
Yes, sir. Okay, sir.
Okay, so this basic whatever things I am teaching to you, like a differential type of code, publisher subscriber code, this thing I provide to you together today. Okay,
Yes, sir. Thank you, sir.
any other question? Hello, any other question? Your question is not audible from me. Please complete the question. Or not understand your question. Please type a question so I can see it. Please type a question. Any other person? Hello. Any other person?
So
Any other
during
person have question?
robothon, we can do in our own systems, right?
For what thing you need? Hello.
Hello.
What whatever thing you
Like
need.
we are creating workspace and packages. Can we do in our own systems?
Yes, yes. If you have a roster, so you can do it now. Package creation for like a publisher subscriber for a turtle sim. You can also start with turtle sim. No need to like a differential type robot like a robot. You can using do a turtle sim. I also provide a turtle sim direct method. Give a some second. I also give you a type. So you can this thing
Okay.
one skin turtle sim. So if you anyone want to hire work, so you can work. Okay, I send a tutorial for turtle sim. See, any other question? Yes, I signed up PPT. Also, this all this PPT and lectures are already I uploaded, and this thing PPT also I sent. So not no need to worry about. Any other question? Hello.
Hello, sir.
Yes.
Uh, if the system is MacBook, how should we install the tools?
Okay. All this I don't know about MacBook how document is set up, but if you want to work on mm, like a MacBook, so I can provide us some repository or some website, so you can learn about this website. I don't know about much more in MacBook because I'm not work on MacBooks. That's why I can't promise and I can't anything songs which don't know.
Can it run on virtual machine Ubuntu?
Yes, yes, we can run on virtual machine. We can run on work on like a WSL, but I don't work on uh, MacBooks, so I don't know about MacBook. You can work on virtual machine, work fine. Also work on WSA if you have a Windows.
Thank you, sir.
Any other question? Do you have any question? Please ask a question like a code or any. If you have any question also after the session, you can also ask the question from by me using my mail ID or LinkedIn, any other matter. So
Excuse
no
me,
need
sir.
to worry about this. Yes, yes.
Can we use Omniverse simulation software instead of Mojiko and
Yes, you
Gazebo?
can. Yes, you can use any other software also, but we are providing Mojoko because I we want to um,
It's for
uh,
referencing.
give a reference or in a one platform which is good for this task. But you can work on any other system also,
Okay,
which
okay,
is
sure, sir. Thank you.
much more good for you.
Sir, this Omniverse, says that it needs UDF file, that is universal something is there, but
Yes, yes.
is it same as
USD
URDF?
file,
Like,
not UDF, USD file. Omniverse
it,
means you are using IJXM, right?
yeah, yeah, yes, sir, right. So,
Uh,
will you
when you are
provide?
working, okay, okay. No, no, I'm not covered for this thing. For this thing, I'm also top publisher want to LinkedIn post, so you can learn about, but I'm not covering this thing at now. Today's session. If we are
Oh,
arranging after this session for this, so I don't this thing after hackathon we will have.
okay, sir. Thank
Any
you.
other question? Please ask a question if you have, or okay. Let's. We are starting then now.
On the day
Uh,
of hackathon,
yes.
like, will there be any GPU facilities?
No, we are not providing any GPU facility.
Okay.
Okay. Let's we start with Mojoko. So first, Mojoko full form is always telling about why Mojoko is better and how Mojoko is mm, good in terms of other simulation software. You can mm, you know Mojoko is famous like this other simulator you mm, Gazebo, Pybulate, and Isaac Sim. This four type of simulator is much more famous in robotics domains. So Mujoko is MU means multi, Geo means joint, Co means Mojoko multi-joint dynamics with contact. Means Mojoko is multi-joint dynamics. You can visualize, see. This is you can do using Mojoko. So Mojoko is open source physics engine, specialized for robotics, biomechanics, animation, and ML. Means reinforcement learning, VLF task, robotics task. This Mojoko is much more used, and also many times your code generated by AI tools, so all these tools inside the engine using Mojoko. This is owned and curated by Google DeepMind. Mojoko without ROS and without any type of your Ubuntu, any type of your Windows, with any type of Ubuntu, not restricted. But when you are doing with ROS, so restriction is come. That's why we are restricting your ROS to humble setup with because we are using ROS 2. So we are using Ubuntu 22 and also providing a Docker for Ubuntu 22 and ROS to humble because we are set up with Mojoko with ROS. If you are not set up with ROS, so you can work in Mojoko Simulator Windows. You can work on your MacBook device. You can work on your Ubuntu 20, Ubuntu 18, Ubuntu 22, Ubuntu 24, any type of your operating system. Mojoko work alone. Okay. It is tool choice for leading researchers like OpenAI and your Google Gemini, and many AI tools. It is widely used as dominant, highly optimized physics simulation framework for reinforcement with RL tasks, sorry, and multi-agent system. Up now, here is a report I am showing to you. Mojoko is work good, much more good for real-time factor. Means, in a Mojoko, you are CPU utilization is much more lesser to other simulator. Let's one paper I have shown. One paper report is figure is shown. Robot is 273% CPU utilization is using and 4.3 is RTF real time factor per robot. But in the case of Mojoko, it's half 116.3 percentage utilization, and Pybulot is 3.3 is higher. Means Mojoko is CPU if you are setting using a server, means server is much more far away. So Mojoko is a much when you are loading a robot, any type of robot or yeah spare. So Mojoko is much faster the loading part. Same for if you are using your mobile system, you are using workstation, notebook, Mojoko, all these places it work much faster than other simulator. Here you see can Mojoko is much good in other simulator. And second is choosing Mojoko. Whatever method you are trained, anything you are trained using a Mojoko, using a RL method. If you are training using a Mojoko, this thing, whatever thing, work in other simulator also, like a Gazebo, Sim, or any other simulator. So generalization is possible using a Mojo. As a agent trained in Mojoko generalize better to other environment than other simulator. मोस्ट स्टैंडर्ड इंजन इंजन यूज यहाँ पे यूज किए जाते हैं मोस्ट स्टैंडर्ड या मोस्ट यूज इंजन इन मोजोको एंड पाइलट also this is benefit for CPU. Agent next simulator ecosystem comparison if you are doing using a Mojoko. So Mojoko uh, in Mojoko is also open source. Documentation well good like Gazebo uh, in Gazebo Classic. So not good documentation is provided, but in at now Gazebo I am not even a name and documentation is at now good for Rospo. But in when you are working on ROS 2, ROS 1 and Gazebo Classic, we are using good documentation, not good. And environment creation in Mojoko, environment creation is tougher, same as Gazebo. But if you are using, you want to create a environment, etc., thing, new things, the Unity mean Ajax like simulator, much more good. Multi-agent robotics task you are doing so much more good is Mojoko, not any other simulator like Gazebo, PyBullet. This is not good for my recommendation, but you can also do using Unity. It means Ajaxium. You can ISO or you can do using Gazebo, but much in your less CPU, less resources, you can do multi-agent robotics task using Mojoko. Visualization, not not much good in Mojoko, like a Kerebo, like a Unity, but other thing is good in Mojoko. Sensor, there are different type of sensor is providing Mojoko. Visualization is also providing good as Mojoko. So at this way we think as a Mojoko is good. So if you want to learning task, so Mojoko is good. If you want a context with dynamic task, control quantum surfacing related type physics similarity task you want to do, so you can prefer a Mojoko. This is a strategy from my side for a loss integration, robotics type, and basic testing. And you want to not learning like you do direct vision learning like a vision task and basic control task and many more basic type you want to work in raw same code. So this I can refer to you all everyone. So you can use a gazebo for a realistic sensor or realistic environment creation, this thing in synthesis data generation, you can use a IXM and Unity. Okay. Now, how many sensor type of if you know, so we are working on different type of sensor when we work on robots. So depth camera, RGB camera, lidar, 2D lidar, 3D lidar, IMU, GPS, radar, tactile sensor, and there are different type of sensor. So Gazebo, RGB camera, there are different type of simulator. All this RGB camera plugin is provided, like a Gazebo, Webworks, NVIDIA IXM, Unity, Mojoko, Copla Sim, Pyblut, all these RGB and depth camera plugin provided. Now, 3D lidar. Webwood not provided. Mujoko also not provided. Coplessing and Pybullet also ABS means not 3D lidar but 2D lidar. All these simulator is provided. IMU sensor plugin if you want to. So Mujoko is partially provided sometime at now I'm not much more. I don't have a check knowledge, but Mojoko at now providing IMS sensor plugin also. But Pivot and Unity does not have IMS sensor plugin, and GPS Mojoko does not have, and radar and tactile sensor plugin Mojoko does not provide. So here is this report. Now this is a basic XML syntax. Your XML for Mojoko start with Mojoko tag. Inside here you giving a model name means your robot name. For our case is lay robot and your case is different type of robot name. And assist means which type of your environment you want to create. And I show you one example so you can understand. Here you see my one second. You see when I robot launch a robot without now I'm doing a this is your asset. So here I'm just one second, one second. See, now we change a plane. Ooh, one second. Okay. See, see. Now we change a here your plane. See here this type of plane. Now you can change also this plane. Now if we not using assist, we are creating different type of plane. Test repetition, grid method. How you want to see your now you grid. If you want, if not, I'm doing this. So see, simple. See now your robot does not have good plane. See, just simple plane. So see that. So using assist, we can change your plane and any other type of your environment, whatever you want to simple minor changes. So you can do using this. I also teach about MD XML file, how you create a XML file. So no need to worry about. And after, if you don't need to write a assist, so not always need to. For this, after this, you write a world body. Inside your world body, everything, whatever you want to XML in the you want to write in your robot, so you write it inside world body text. This is world body tag started, and here your world body tag is ended. Inside your robot configuration, your robot uh, uh, robot types, link, joints, and all these things is created your world body tag. So after world body is tag, next mandatory tag is body, and after world body tag ended, you can write a your motor body like a my robot. I'm using a differential type to motor is two wheels means two motors is needed. So same thing I'm doing. Now we are understanding XML file. Okay. See, first tag is my Mojoko. Inside Mojoko. Yeah. Okay. I think. See, no one see. Now everyone see the code. Hello. Code is visible or not? Hello.
Yes, sir.
Okay. Uh, I show you before. Mojoko, first we start a whatever if you write a XML file in for a Mojoko, because Mojoko read a XML file. But if you are write a you RDF also, sometime like many more methods as providing. So URDF direct convert in a XML and then work in a Mojoko. Write a XML Mojoko not supported URDF file. Okay. So Mojoko supported a XML file. Okay, but URDF or XML is much more same. So no need to worry about it. Okay, Mojoko. After this, here you can write a model name, or if you no need to give a model name, so you cannot not. So here I am not giving any model name. You can also give or not. It's your personal choice. Assist is your no need to mandatory to write if you want to something new environments to create like a I show you a plane different type of plane creation, so you can write a, inside your assist tag. If you want you not need to create any plane different type of plane, you want to simple plane, so you need to worry about assist tag. Okay, now here because Mojoko have different type of, let's just I am launching Mojoko, I think. Oh, I can no nobody. Okay, simple. Mojoko support a physics system is Mojoko. So air provide a gravity. So gravity which axis we are because we are all down in Z axis. So gravity is minus 9.81. We know that. So option gravity is by default is provided. This is also not mandatory, but I recommended you in all your XML file always write a gravity. Okay. Now, after that, in mandatory tag is world body, because all physics object in the world, whatever means this is your college is one world. So whatever thing is inside your world body. So here you need to first world body. So when world body tag is started, so world body tag is also ended. Now here you see world body tag is ended. Inside world body tag, you write all your link, joint, and how link is which type is created, where position is link where, and all these things is here you can write. And also light, which type you want to light focus, where camera, all these things is here you can write. So I'm using here different type of lights for better visualization. You can have one light, so light inside your light type diffuse, you can use a diffuse to diffuse, so light color intensity, and then you pose where you want to give a position and direction for light, and cast shadow, something ki shadow want to you see the your robots. Just I see the shadow of my robots, because this is ground plane light focus so you see the when I show your my robot, so shadow is seen, so cast shadow is true. Now I also give a light different direction. So here you see light a side light for fill and back light for rim effect. So I'm using here three type of light. Means you inside one room you are uh, uh, mm, using a three light different type, different location. Means three bulbs using three CFL is using, or different type of light using for better visualization of your rooms, your house, like this, your better visualization of your mm, your robot. You are using different type of lights. Okay, different angles. Now, geom type palette. Geo means geometry. Type means you are using plane, and size where you how much size you want to see your plane. So I'm using five, 5 in x5 y5 and z 0.1 means I'm not your plane want to in air. So 0.1 or 0, it's your choice. So I'm not creating a plane much more higher. You can here you can write a grid size you want to 50 by 50, so you can choose a size any size. Now, RGB means R means red, G means green, B means blue, A means appearance. If you set a zero appearance, so nothing your plane is not visible. If you see set a one, so your plane is visible. Point 0.9, point 0.9, point 0.9. This is combination of red, green, blue, and you see the robot. So you can here if you say one or other two value is zero, so your plane is shown red color. If you see this, so here you first value is one, first value is zero, second value is one, and third value is zero. So your robot is plane is green color. In your robots and in green color inside plane no, outside of sorry plane green color plane in Europe. Now I show you my robot. So in robot, first stage, three component is one wheels. Sorry, two wheels, one chassis, and other one is custom wheels. This four links is mandatory. So first need to create a body. So body name is my chassis, because we are creating body. So body name is chassis. Where you want to this body to uh, uh, actually presented. So pose is by 0, 0, and some height I want to load a body 2.2 means in z axis, and I want to rotate a body in which axis, in which 90-degree I rotate up my body. So this is done. After that, creating a body. So this body means chassis. I am using a fixed joint means this body is free when you want to. If you are using means URF, so joint type is fixed. But if I'm using a XML format, here you need to XML format to here it joint is free. Okay. Now after creating this body joint type, now define your body structure for this. uh, you write like in your if you are using a URDEP, so body place you are using a visual tag. Visual tag, inside your visual tag you give a position, orientation, and visual tag name also. So here inside visual you also take a geometry tag. So here a same type. Geom means geometry. Type is your geometry type. Which type of object you want to load, means there are different type of geometry, means box, cylinder, or sphere. So here I'm usually utilizing box. So box is three dimension, x, y, z means length, breadth, or height. So x in 0.05, y in 0.2, and z in 0.6. So we are cases created, and RGB value also here I saw. So you see one cases in much I and color I think I say yellow, and then we created a marker, means this is your current position you are setting. So site marker position is your now current position. Here you created a marker 0.0, and your marker size is 0.14, and I don't want to visualize a marker, so I'm setting a tag RGBA in 1. So just is for extracting your current position, not a sending a data. Okay. Now, after that, your robot chassis is created, and you set a one reference point where which you using if your chassis is move, so position is updated, so marker is also set. Now you are creating a body left joint, left tire. Now after this, you creating a body full right tire. So body name is left tire. Then pose it because chassis is left side, so in y direction pose is 0.26. Okay. And z is minus 0.05, because your robot chassis is already in height, so you can set up robot chassis in left direction and something down to, and by default your chassis is in the plane. So we rotate our pole. So your chassis are now in your robot left side. But as your chassis is cylinder type, so geometry type is cylinder, size is this XYZ, because X or Y cylinder here. So radius and length we are providing, and RGB value this is provided. So you see, and joint type is hinge. Hinge is actually similar to revolute joint. Here, joint type in name different. Hinge or your arm, all type of when your URL file is converted in XML. So joint type is hinge. So no need to worry about and no need to confuse of this. And because your a revolute joint have 1 degree of freedom, so I am rotating is in your which direction? Z axis. So here I am providing a, because wheel is rotating in Z axis, and also your arm different your all you see 5 degree of rotating arm. So whatever direction you are rotating, x direction, y direction, anyway, so you are providing axis here. So my case is -1 and your case is different. Okay, because we are rotating around Z axis. Now everything is created for left joint, same is right joint, but here position is just changing minus to plus in y direction, and nothing is changed, just body name is changed and other thing is not changed, and joint name is also changed. Now we are creating same way wheels. Now you created wheels same way, and after creating wheel, body is ended and body is ended. Now adding a sensor for your marker. So we OBJ type sites we use your sensor at. So here using this, you know the current position of the robot with respect to world frame. Okay, and this is plugin for your wheels means wheels for left motor, right wheels for right motor. We are providing velocity, so we are here setting velocity servo motor. So left velocity servo motor. So joint is left wheel and joint is right wheel, which we are given, and kV means we are saving. K means gain, and V is velocity. We are providing maximum velocity 100. Same way we can kV means gain how much we are providing to, and same velocity. Name is right velocity servo. We or joint is right wheel. So name is right velocity servo, and name is here joint type is right wheel. And kV is same 100. Now actually, so this data in your code here you have to send your simple Python without one second. And your when you write a simple Python, no need to worry about different device. When you just start with simple basic, बिल्कुल base without base, nothing बिल्कुल without basic to basic. So you do this way. So data dot control CTR dot first parameter inside zero. You can library CTR data dot CTR inside first parameter you are providing left with velocity, and data dot CTR one you are providing second velocity. Means this is array, and inside array one by one value where we extracted and pass it the to the same way you are seeing your different arm. So I'm also show your arm example. One second. Give me time. How you know everything? First stupid space SRC Morocco launch. See here you see first go to your launch file, and you see inside your where you can find your package related arm S0101 unified bring up inside. You can find it. So first you go to inside S0101 place. So you see the your arm URL file unified. Just one second. Unified bring up. And here you see launchpad. Inside launchpad you can go again main file. So you can find out your XML file or whatever you are creating. Or this is gazebo. Also, I think we can provide also with gazebo, but we are recommended with second. Give me a time. Okay, this is your URL file also. Here you see all these things. Link name, whatever where we given a name like a body, here is a link name. Base link, your inertial geometry, you this link name is a world body like a, and this link name is you think as a world body, and for XML, and if this is visual and with geometry inside you provide a STL file location, and after that collision, and there are many things it's providing visual collision, and as I said tag is need to maintain it. So this file is also converted when you are launching. So XML after this is XML is converted. But I need to see where is uh, after this I so anyone has person have doubt, please ask. Hello, hello. Any person have doubt? Please ask the question. Hmm. See, your this is your example file for your robotic arm. Now, hmm, till now we are covering Mojoko. Please ask a question if you have any doubt. After that, I show just a Python code, how you do launch your robot in Mojoko and etc. etc. Anyone have doubt? Please ask a question. Okay, I can think no one have doubt. Please, if you have any doubt, please ask a question in between also. So now I am showing how you load a robot in Mojoko using a simple Python code or any medium. So this is just simple Python code. See, import Mojoko. I am import Mojoko as MJ means I'm just giving a new name. I'm Mojoko viewer because I want to see my robot in Mojoko viewer inside Mojoko simulator and import numpy as np because I'm doing just basic operation of numerical operation. So numerical Python is importing operating system because we are loading XML file in different location. So we are setting a links means path. So we are importing OS, also importing time for we are launch loading a robot in some after time and fetching a data as after some time. So for this, we are uh, taking an input time trading for multiple task management and importing GUI because I'm utilizing also GUI. And I'm not showing to you, but I'm utilizing also GUI and um, and also giving a TTK is just simple name or a simple purpose. Left speed, initially your I'm not providing any velocity for your robot, so left speed initially 0, right speed also 0, and running is true initially. And here os.path.join giving differential drive dot xml. So using this, we know the our current location or package name. Here after inside your package, I'm giving a XML file. So XML file we're providing with this. See, in my case, see the XML path. See, this is my XML path. So inside this code, it directly read to me inside this folder, and then XML file is this. So using this, we are extracting whole XML file. Now we are launching a model mj model means mojoko.mj model dot from XML path. We are launching your model. Now your model is data is extracting mj dot. We are talking with Mojoko data. We are extracting using your model. So data we are extracting. Now we are initially your because initially your robot. I don't want to move the robot. So data dot control we are first in left motor we are providing zero velocity. In right motor we also providing a zero velocity. If we are not providing initially zero velocity, so your robot have some gain, so it automatically move left, right, forward, backward, any. So random area is coming, so that's why we are initially stopping the robot. Okay, now for controlling your robots. So we are providing left velocity, means left speed, right speed. So we are not providing much more left speed or right speed. We are restricting at -10 to +10. So left speed is -10 to +10 is restricted. And clip LR. So we are providing left speed left or float, whatever velocity you are providing. I'm restricting -10 to +10 or in and converting in float value, and then sending using a data.ctr dot uh, uh, 0 and 1 in left motor or right motor. Okay, and then mg dot set mcbg controller using whatever meant mcbg controller is providing a motor speed to Mujoko simulator. So this function using we are providing speed to motor. Now we are creating UI. This is not a novel part and no need to worry about you. So I'm not explaining to you. Here, this function is depth set speed. So we are setting speed, left speed, right speed. So for setting speed, forward velocity we are 2 setting set speed, and for this function calling this function left velocity 2, right velocity plus 2. So left velocity here 2 and other plus 2 is setting. If you are creating a button, uh, mm, uh, means pressing a button backwards, so this velocity is good. Pressing a button down left, so this velocity is good. Pressing a button, so this velocity means robot left or right together velocity in both motor is providing. And if you are want to stop, so 0 0 velocity is good passing. And this is a button, so you need to worry about for closing global running. We are here stopping the report, and when you destroy the report, so we are clicking a cross sign. So it is all the window is your stop. Now, main this is your code because we are using a GUI, so we are creating a thread. And when a thread is started, UI is started. So your Mujoko simulator, Mujoko viewer is launching. Mujoko.viewer.launch you passively to your launch हो जाता launching your robot, your model is visualizing your simulator, and also data is coming as well. So we are Mojoko robot simulation started. Control button also is shown in your terminal. Also, while we are engineering your Mojoko simulator is running. So after some second or some step, your data step is calculating and synchronized viewer is shown with Mojoko. If you are using Mojoko always together, so synchronized data is also shown. And after some delay, mm, uh, uh, we are sleeping your system means some micro mini silicon is your simulator is closing and then again loading that, but our eyes is not seeing, so small delay to prevent maxing CPU utilization. Then this is it. Your robot started and ended. Using this we are launching your robot, and this is your just button, so we are not worried. So this is all about your Mojoko. This is all about your robotics. Means Ross now need to remain only move it. If you have any doubt, please ask. After this, we end mm, give a one basic knowledge about only move it, and then session is end. Please ask a question. Have a 7 minute for asking a question. This topic also. Please ask a question if you have any question. Anyone have question or not? So I continue the next session or move it. Hello, I'm audible. Hello, any question? Hello, hello, Omkar. Any question? Hello, Jivan. Anyone? Any question? Okay, let's We are going next topic uh, about Mojoko. So we are launching a Mojoko beta arm. So now let's start with move it. So move it is a open source robotics framework. It is widely used for motion planning, manipulation tasks. For most of the time, this is used for robotic arms and complex robots. Most of the Mojoko also closely uh, work with robotic operating system. ROS 1, ROS 2 both is for ROS 1 move it is move it, and for ROS 2 move it underscore move it 2 is provided and now is available. Okay. Uh, what things move it does? So move it actually help the person or help the robot to move safely and efficiently in real world or any simulated environment like a simulated environment move you think as a uh, you can think as a simple also 1 second think as a gazebo or a mojoko any other simulator environment you can see that. So now first we see the your depth camera data in RVs. So we are also one RV also loading. 1 second. What up? So see your camera data inside your now. Both can see your take camera, your RVs. So here you can go. First you go open RVs and then you go add and you go add images. Here you see your image. Here you set a topic. I can see not here working. So I also here also here you can go add. You can go images and now you can go add. See no image topic CG is also seen after this, but after this here you can change your topic name like so you want to see depth image. Here you see your color image is shown. Also you see your depth image using depth topic. See your depth image is also shown. You can also visualize your data using ROS to topic eco ROS to pick list. Now you want to see your depth camera plugin camera intensity parameter. So you can write a just ROS to topic eco and you see your camera intensity parameter. Also your everything whatever you want to see. So you see your data or particular topic and intensity parameter and all these things you are seeing here. This is your frame ID for this topic, and this is your just d value. This is your intensity parameter means this is fx, this is fy. Sorry, yes. Wait a second. Yes, yes, yes. This is your fx. This is your fy. This is your cx, and this is your cy. So this is your intrinsic parameter. Also, you see many other things, whatever you want to see. Now, after understanding this, now we go to move it again. So see, move it. A key feature is motion planning. Kinematics means forward kinematic using move it. We can mm, uh, value fetch and also inverse kinematic also you can fetch. Collision detection we can also do using a move it. Trajectory execution, if you want to move the robot like any medium to any position to any position, so you can do using a move it. Just a simple, I'm start a state is current state where whatever position robot, and I want to goal set goal state is random. I want to say goal state any random, and start and plan and execute. So you see your robot move, see any random place. So it's plan a motion and also inverse kinematic for that particular random position, and also avoiding the collision with respect to given object and move the. Uh, in future, you can also add a perception, whatever thing, whatever you want to do. So all these things you can also here you can add. Uh, Using a Mujoko, move it. You can give a target location, means XYZ, also orientation. Also, move it, calculate your joint angles, plan a shape path. So, for this, there are different type of method. Under the Mujoko, you have a by default OMPL. So, you see that this is OMPL means Open Motion Planning Library. So when you click a context, you see planning library OMPL, motion planning library. Inside for inverse kinematic or whatever for this thing, uh, Mujuko by default using KDR or TechIK or kinematic star or collision checking whether etc. task using Mujuko is FCL. So there are different two type of Mujiko version. Move it one, for move it simple so for ROS one and widely used in stable. Move it two, ROS two humble, and they are all the ROS two version. But some issue is in with move it two, but not move it one. Move it is basically the brain of a robot motion. Without it, you manually control each joint. Without move it, you can control the robot also and your arm also. But you can't. You want to do any other things. There are different type of method, but you can't. For this, you need to go and give a 1 month, 2 month for your control arm. But with move it, you can control a robot automatically plan intelligent movement. So because inside this, oh, there are different type of planner which also available. You see e-planning method, approx IK solution, collision, use Cartesian path, and there are different type of things are available. So you can see that. Also, you want to add a scenes something from your robot, so you can add. You want to see your which link you want to see. Choose the link to attach. So you want to base link you want to set. So you can your ground plan change your ground plan at your requirement. Also, you can store scenes. Here you can any see like here your robot is one area object and other object here. So you can here you can store your scene. Also store state here using any method. So also this is available status. You can see change also goal status, and you want to add any object or detected object. So you can add there. And now manipulation detect this is also also without you want control without any move it and just you want to control your uh, arm using a direct joints, so you can hit that lead you can also control. See, so you can control via this method after control it, and you can uh, set semi start and plan and execute. You can do. Okay, this is your all about move it also. And if you have any doubt about move it, any doubt about anything, please ask a question so can I can give an answer. If you want show the code anything about, so I can answer. Please ask a question. This is last session for today. Um, uh, I am giving one example for how movie works with ROS. So just you are sending a goal, means end effector pose. In you want to your end effector reach to particular position. So you are giving just XYZ, move it, receive using a move group. So you also need this using, I think wait, one second. No, here you are. Mm, yes, we see move group. This see using move group, you send a your core node, means your end effector code using move it. So move group using you can receive your pose planning starting using a OMPL computer collision free trajectory. Now using a move groups topics. You see here now ROS 2 topic and list. One second. So I show you move group, move group. This using here we are using this. So this way we are sending your move it update state, roll state, or we also send a trajectory topic, trajectory execution topic using data. So here this is your robot description where your robot all description is actually started, and move it communication we do using move group, joint state, or trajectory execution. Okay, so trajectory execution this is using this move it or joint state using we do move it communication, and control execution we do using ROS2 controller, which is automatically generated when we do Mujiko setup. So this is all about Mujoko, and inside Mujoko, there are different type of plan: RRT, Connect, RRT Star, PRM Star, EST Star, EST, and there are many type of planner is available with Mujoko. Sorry, move it. So this is all about today. Please ask a question if you have, and no, so we can end our session after 10 or 15 minutes. Anyone have any question? Hello, any
No, sir.
question? All is clear. If you have any question, please ask. I have till 9:50, so you can ask question after the end the session. I don't have idea for Docker image for Vboard also will be provided. No. Gazebo, I think, and Mojoko, we are providing Docker image, not for Vboards and other many more simulator. Any other question? Hello, it is your question is answered. Okay. Now, any other person, if you have question, please ask. Any doubt? If you have any doubt, you can ask me via LinkedIn or using a mail, so I can answer your question till your software round is started. After that, we can't help you. Then you have to work on your hackathon problem. After hackathon, you can also ask the question.
So you told you will give the URDF files, not the exact Docker file, the one
We
from
are
your side.
providing a all Docker file, URL file, everything we provide. But today we are providing all just we you need to practice. So we are just providing a my XML file and Python code. No other not other things. Okay. Hello.
Yes, sir. That is fine.
For today I'm not providing it. I can provide a other thing and team also provide you all these things. But after the uh, mm, I think after the tomorrow, day after tomorrow, max to max day after tomorrow, or tomorrow we can also provide. Let's see how if issue is resolved also we can provide us tomorrow. Okay. For any question you can ask a question via this mail ID. It's provide to you and also mail ID so you can ask a question. This is my mail ID, so you can ask any question if you have. And once again, I also provide a link ID, so you can also ask a
Thank
question. Using this two medium, you can also ask a question any if you have. I also provide a today Python code and XML file for practice. You can do a practice. I provide a XML file for 2 hour no, for not a differential driver, so you can practice on 2 hour arm. So good idea for not this. Okay. Hello. Any doubt?
No, sir.
So we had the session. Or anyone have doubt? Please ask.
Is there any extra workshop tomorrow, or is it the last?
I can. This is last. If other member want to any doubt, if you have other person, so we can arrange any other workshop. Otherwise, not.
When we get the Docker file, then we will have some doubts, sir. When we give that at that time, we may have some doubts.
Yes. If you have doubts, so you can mail our team, or if you have basic doubts, so you can ask me a direct this two medium via LinkedIn or via message. Mail. If you have much more doubt continuously, then you can mail to our team. So team arrange a session for this. Okay. So basic understanding about ROS, Python, and Mojoko. Uh, Move it or not? Because this thing is basic. If you don't know this thing, so how you can work on uh simulator or hardware? How? है ना? Omkar, till I'm asking the question again and again, last one by one. If you have to, please ask. Tanmay, any question? Omkar,
No, sir.
okay. Uh, Sheikh, from your side, any question? Okay, no problem. Yasnia,
No, sir.
okay, no problem. Lokesh, I think Hitesh, do you have any question? Okay, no problem. Jeevan, Mubisen, okay, I can.
No, sir.
Okay, so then we are ending today's session. I can also team sending a recorded video. Okay.
Thank you. Is it done? Rahul?
Yes, ma'am. Yes, sir.
Well, so I hope almost all participants got some basic fundamentals and ideas with respect to the various platforms like ROS and simulation platform like Muzako and Move and all. You can use any of the simulation platform. Anyhow, for the participants who are missed and all, we will be we have the session is being recorded, has been recorded. We will be sharing you the link of this recorded session, so you can share it across to your participants and you can practice that kind of it. If there is any doubt, you can feel free to share it in the group also, so that participants can, our team can assist you and help you in that, right? So thank you one and all. In that case, we will be ending the meeting.
Okay, sir. Thank you.
Thank you all.